Okay, welcome back. Here is interval video number 2. You can see I still have my chart up here. Let me grab my eraser here. And we learned about generic intervals and then the interval qualities of major, minor, perfect, and then this stinker one here, augmented fourth and diminished fifth, or the tritone, the Diabolus in Musica, as I mentioned. And so make sure you understand this before you move into this one. So if you are a little fuzzy on this, go back and work on this until you get it, and then come back to me here. Okay, so what I'm going to show you now is that intervals can be inverted or flipped upside down. And that's all inverted means. And inversion is actually a quite common concept in music theory where we take all kinds of things and flip them upside down. We can take chords and flip them upside down. We can take melodies and flip them upside down, and that's always called inversion. So all inversion means is we're flipping it upside down. And there's a little trick to know what you'll end up with if you invert any given interval. Okay? Um, and so what happens is, and let me just show you, we're going to do C up to D. And we learned last time that's 1, 2. This is some sort of second. And then we also learned that there's a number of half steps between it. So C sharp D or C D flat D, C sharp and D flat being the same pitch. It's um, two half steps. And so that makes this a major second. A minor second would just be one half step, right? We learned that last time. So what I'm going to do is I'm going to invert this interval by flipping it upside down. And what I get is if I count, so I just take the C and I bump it up with what we learned in octave, right? So all the C's, right, are octaves apart. So um, I took my C and I put it on top. So I inverted the interval. And so now I'm going to figure out what I have. So 1, 2. Remember, you have to start on the D here. 1, 2, 3, 4, 5, 6, 7. So that goes to a 7. Okay. And then we would count the number of half steps, right? And figure out that this is 10 half steps. Go to a keyboard and count it yourself. Go from D up to C, and you will see that it's 10 half steps. And so that means this is a minor seventh. Okay? So I've inverted my interval from a major second to a minor seventh. I'm going to show you one more example, and then I'll show you the trick. So let's do C up to E flat. So I want to figure out what the generic interval is. 1, 2, 3. It's some sort of third. And then if you count the half steps, you'll go C, C sharp, D, E flat is what I would say. I should have said C, D flat. That's one half step. To D is another. And then to E flat. That's 3 half steps. So we have 3 half steps. So if it's 3 half steps, that means we have a minor third. 3 half steps are always a minor third. It's just the way it is, minor third. And if I had gone up to normal E, E natural is what I should say, that would be 4 half steps, and that would be a major third. So hopefully that basic interval stuff is in your heads. So what I can do is I can invert this guy here, E flat to C, okay? And maybe I should be writing these a little bigger so you can see them. E flat up to C, that's 1, 2, 3, 4, 5, 6. Our generic interval is a sixth. So this is some sort of sixth. And if you go and count the number of half steps, you'll find that it's 9 half steps and that this is a major sixth. Okay? Let me do one more. I want to do C up to F. Okay? 1, 2, 3, 4. This is a fourth. And we learned last time there are no major or minor fourths. There's only perfect fourths, or the Diabolus in Musica, which means augmented fourth, right? So that's an exception there. But there are no major and minor fourths. We have a perfect fourth. Well, if I invert this, you'll see if you count it all up, you get a perfect fifth. Okay? By the way, this is 5 half steps, and this is 7 half steps for their intervals. Okay? All right, so I don't know if you've noticed a pattern here, but the way to invert intervals in your mind quickly is this little trick. If you've noticed, when I inverted my second to my seventh, it adds up to 9. 2 plus 7 equals 9. 3 plus 6 equals 9. Can you see that on there? I hope so. 9. And then 4 plus 5. 4 plus 5 equals 9. So if I invert any set of intervals, the generic number will always add up to 9. So if I have a second, I invert it, I know it's going to be 7 because 2 plus 7 is 9. Okay? If I take a sixth and I invert it, I will get a third because 6 and 3 add up to 9. I'm going smaller to larger intervals here, but you could go the other way around. Okay? So there's that. And then the final trick is perfect intervals will always invert to perfect intervals, and major intervals will always invert to minor intervals, and vice versa. So the generic interval needs to add up to 9, and then you get the opposite quality if it's a major or a minor interval, so major to minor, and then perfect intervals stay the same. So if you know that, then you can invert these things quickly in your head. That's it for this video. Let me know if you have any questions, and good luck on your homework, and we will see you in the next video at the keyboard. Boop, boop, boop.